Alrighty, hello everyone. Welcome to Getting Started with CI/CD. Today we're going to be using AWS, Pulumi, and GitHub Actions. My name is Diana Esteves. I am a solutions architect here at Pulumi, and with us we have Marina. Marina, you want to go ahead and say hello?
Yeah, absolutely. Hey, everyone. Marina Novik. I'm a senior partner solution architect at AWS. I work with Pulumi for several years on improving integrations and support for AWS customers.
So first, we are going to shortly cover DevOps and do an introduction to Pulumi. I'm actually curious if you can let us know in the chat what is your experience with Pulumi? Are you new to it? Have you used it in the past? Or you're currently learning? Right? It helps us understand where you are in your journey with Pulumi. And then we're going to get to the fun part. We're going to do a few live demos. The first one, we are going to build a static website. Of course, we'll be using AWS S3 and CloudFront in particular. Then we're going to move on to our second demo where we are going to take the first project and add an infrastructure CI/CD pipeline, and we'll do so using GitHub Actions. And then we'll go ahead and shift into a bit more advanced Pulumi topics that may help you as you mature in your journey. Now we'll also have Q&A. Marina is here to help us with a lot of the technical questions and a lot more. So feel free to ask questions as you have them. Definitely don't have to wait for the end, and we'll try to answer a few questions as we walk through today's agenda. So with that, let's go ahead and jump into today's material. So we're going to start with a 10,000-foot view that will help us set the stage for today's workshop, and that is answering what is DevOps. So DevOps in today's world, right? It depends, the answer. What you see here under the how-to column is a set of practices or technical capabilities that tend to encompass what it means to do DevOps in today's world. This is as per the State of DevOps report from last year. So it does tend to shift slightly year over year. So the idea is that if you are adhering to this set of practices, right, you are likely maximizing your software delivery performance. And software delivery performance is measured by 4 key metrics and a fifth one that was recently that was added shortly thereafter, which is reliability. So these are the metrics shown here on the right-hand side. Now, coming back to the how-to section, right? Today we are going to heavily focus on continuous integration and continuous delivery. However, these practices are not in isolation. They tend to influence one another. For instance, having a continuous integration solution in place, right, likely means that you're going to speed up your code review cycles. Now, the ones that you see here in bold under the how-to section, they tend to have the biggest impact in your software delivery performance. Right? So that's why I wanted to bring them to your attention. Again, just to cover it quickly, what does continuous integration mean? It means the ability to automatically build and test any software change. Whereas continuous delivery, it means making those changes and pushing them to production effectively. Another way to think about continuous delivery is to ensure that your code is always in a releasable state. So why we want to adhere to these practices? Well, because we want to maximize our software delivery performance. Now, that is DevOps in today's world. Again, some of these practices may slightly change year over year. Now, you may have also heard the term GitOps, and GitOps and DevOps are related. Imagine all those best practices, so everything you saw under that how-to section, right? You take all those best practices and you apply them to infrastructure. In a nutshell, that is what GitOps get you. Now, infrastructure, it's not so much physical infrastructure nowadays. It's more of a cloud resources and the life cycle of them, right? So infrastructure could refer something like an S3 bucket, a Lambda function, an EC2 instance, and so on, right? And with GitOps, right, everything sort of revolves around the idea of having a version control solution in place for your infrastructure. So what that means is that you want to define infrastructure as code, and that is when Pulumi comes into the picture. So Pulumi is an infrastructure as code solution. We say modern because it fits naturally within the larger development ecosystem that you already have. In addition, with Pulumi, you can use already familiar programming languages and tools to define your cloud resources. It also works with any of the major cloud providers. Today, we are going to be using AWS, of course, but there are many other cloud providers that we integrate with. Two of my favorite things with Pulumi is it's open source. They use an Apache 2.0 license, and there is also a free tier for the managed SaaS offering. This is actually what we'll be using today. It's called the Pulumi Cloud. We'll learn more as we progress through today's workshop. So Pulumi is very flexible, right? It tends to be cloud agnostic, works with any of the major players in today's world, AWS in particular. Today, we will be using TypeScript. However, you don't have to only stick to TypeScript. Pulumi works with Python. It works with the .NET framework. It works with Golang and Java and YAML as well. Because you are defining infrastructure in any of these programming languages, it means that you can leverage the ecosystem. Right? For instance, you can develop code in your Visual Studio Code, which we'll be using today, and use your existing source control solution. Today, we are going to be using GitHub. There are over 150 different integrations. Right? So these are all resources that you can define with Pulumi. So if you want to learn more about what you can do with Pulumi, I invite you to head over to the Pulumi Registry, where you can get familiar with all the different packages that we have. Today, we're going to be using mostly the AWS package to define our cloud resources. These are not, you don't have to use one versus the other. In fact, oftentimes you will see that a solution is actually composed of various packages. So Pulumi is not the only infrastructure as code solution out there. So I just wanted to quickly compare it to the major players in the IAC space and see where Pulumi stands out. So as we said earlier, right, general purpose programming languages will be using TypeScript. You can define resources in any cloud, and it also offers a local CLI deployment model. We'll be getting familiar with that today. But what it means is that you don't have to go to another service to then deploy your resources. So essentially, you're typically saving a network hub, which means things might be slightly faster. Another thing that Pulumi offers is it has a built-in mechanism for secret handling. As we'll see shortly, we have this concept of stacks. So it automatically creates an encryption key per stack. And as long as you declare something as a secret, Pulumi will go ahead and encrypt that secret with the encryption key that is kept in the backend, right? In our case, Pulumi Cloud, and stores the ciphertext in the configuration file. This is quite powerful because what it means is that you cannot leak anything if somebody takes a look at the configuration file. which then means you can commit your configuration files in source control. So this is what we're going to practice shortly with our hands-on demo. And the Pulumi program model is as follows. You have, at a higher level, a project. You could think of a project as a directory in your source control. And within that directory, you are going to have a Pulumi YAML file. The presence of this file is what denotes that this directory is a Pulumi program. The Pulumi program, what we're going to do is define various cloud resources that we will like. Right? So you can imagine if I want an S3 bucket and I want 2 objects in that S3 bucket, I'm going to go ahead and define these resources in my Pulumi program. In our case, we'll be using TypeScript. What this means is that Pulumi is declarative. It means you defined what you want, and behind the scenes, Pulumi is responsible for instantiating those resources that you have specified. You can also see in this diagram that you have the concept of inputs and outputs. So you could think of inputs as arguments for an object, and the outputs, the properties that you can access for that given object. Oftentimes, these resources depend on one another, right? If I want to place an S3 object in a bucket, right, I have to know what that bucket is, right? So that creates a dependency between the S3 object and the S3 bucket. Pulumi is pretty smart. It figures out all these dependencies for us where it's implicit. We can also explicitly create dependencies. So how do we bring this thing to life? Well, we then have the concept of stacks. Stacks are YAML configuration files within that same directory. You could think of a stack as an instance of the Pulumi program. A stack file typically represents an environment such as development, QA, and production, right? So these stack files will differ from one another. Right? For instance, you may have different AWS regions specified in each of these files. You could also have something like your, say, EC2 instance size. Right? If you are in production, perhaps you want a larger instance, whereas if you are in one of your lower environments, you don't want to incur as much cost, so you want to stick to some of the lower instance sizes, per se. So with that, now how do we deploy this thing, right? So this is where the Pulumi CLI comes into the picture, or what we call the Pulumi engine. We will be showing this here shortly, but if you look at the left-hand side, this purple box, right, has a project, has a Pulumi program with the various files. So how do I know this is a Pulumi program? I have a Pulumi YAML file. In this case, I only have a single stack, which I call dev. And then you have the entry point file. The entry point file will depend on the programming language that you're using, right? If you're using Golang, it'll be main.go. If you're using Python, it'll be _ main, and so forth. So what happens when you are in front of the terminal and you type Pulumi up and press enter, right? The Pulumi engine is going to kick off. And what it's going to do is going to take your Pulumi program and your stack definition and see what it is that you have specified. And it's going to see, okay, you want an S3 bucket. And for that, I need the AWS provider. So let me go fetch it from the internet and download it locally. Now, we don't use anything novel here. We don't use anything different, meaning that if you are using TypeScript, we are going to be using NPM modules for the package manager. Right? So again, because we're using programming languages, we leverage the program's native package manager. So we go ahead and download those NPM modules which have our AWS provider in this scenario. And it's going to go ahead and start provisioning the resources that you have specified in your Pulumi program. Now, by default, the state of how your resources look in the cloud is going to be stored in Pulumi Cloud. I would say Pulumi Cloud is the easiest way to get started. Managing state on your own can be a little bit tricky. So we are going to use Pulumi Cloud for our backend solution. It's the easiest way to get started. It will also handle any secrets that we have by encrypting the values in that file. So what this means is that if you haven't already, you should have gotten an email with an invitation to a Pulumi Cloud account. In this particular Pulumi Cloud account, you will find a final running version of today's workshop. It will remain active for the next, I believe, 2 weeks or so. So I encourage you to go ahead and join. Take a look at what's there. We're going to be showcasing a little bit of Pulumi Cloud today. But the idea is that you can have a working version of today's demos so that when you're following or when you're replicating this back at home, right, you have something to refer back to. All right, so with that, we are going to go ahead and get started with our first demo. So we are going to create a Pulumi program. And in this Pulumi program, we are going to use S3 and CloudFront resources to deploy a very simple application. So I'm going to go ahead and switch over to my Visual Studio Code. All right, so while we're here, let me just go ahead and check our Q&A. How are we doing in the Q&A, Marina? Anything interesting to share?
I think for current state, I think we'll cover it. So just let me know if you have additional questions. I think I have never seen the question like that. Why you name it Pulumi? So I provided the answer there. So if anyone interested, yeah, the answer is in the Q&A. Yeah.
Yes, that's a great question. Pulumi is a Hawaiian word.
Yeah, of broom, which is
yes,
interesting. Yeah.
Awesome. All right, so we are going to continue on to our hands-on demo. And in this first step, we are going to create a Pulumi program because what we want to do is define infrastructure as code, which is one of those best practices under the DevOps, GitOps world. All right. So the first thing is I have a brand new folder. There's nothing here. Everything is empty. To get started, I need access to an AWS account. And I also need access to a Pulumi Cloud account, which I have. So let me just validate that I have my credentials set up correctly. So for that, you can do who am I? And yep, that's my username for Pulumi, so it means I am logged in. And then I want to make sure I did configure my AWS credentials. So our Pulumi program is going to, by default, use the credentials configured in my local machine. I can, of course, override those credentials if I would like to use an alternate account, but this is what we use by default. So to get started, I am not going to create a Pulumi program from scratch. What we're going to use is bootstrap our solution by adopting a Pulumi template. Pulumi templates are the best way to get started with Pulumi, I've found. We have over 100 curated templates of just about everything you could imagine. in a number of programming languages to get you started with defining infrastructure as code. So today we are going to be leveraging one of those templates to deploy our solution. These templates are in a Pulumi/templates repository. They are open source. You can also define your own templates and reuse them or share them in the future with your team members. So the template that we are interested in for today's workshop is called, let's see. I think my font is a little large, so let's go ahead and do this. Okay, so it's going to be a static website, and we're going to be using AWS. And in our case, we want TypeScript. So we're going to go ahead and select our template, and then it's going to ask us a couple of questions about the template. For instance, we want to give it a project name. So let's just call it live workshop, and we can leave the description default. We can also use the default stack name. So after this, we're going to be asked very specific questions to this particular Pulumi program. For instance, it's going to prompt us for the region. We're going to be using US West 2 region. And because we are deploying a static website, we already have two dummies, if you will, error and index pages that the template has. So we're just going to go ahead and use those. And they are going to be in a www folder. So once I am done with my configuration settings, Pulumi is going to go ahead and download any dependencies that I have specified. Again, we are using NPM for this solution. So what we did is all we did was run the Pulumi new command and select a template from the hundreds of templates that we have available. So with that, I have now created a Pulumi program. You can see that it automatically populated all of these files. And we know this is a Pulumi program because I have my YAML file. In this program, right, there's one thing that's really critical, and that is the runtime. Because Pulumi supports such a variety of programming languages, it needs to know how to compile this code. And it compiles it based on the runtime. In our case, that's Node.js. And then we have our specific stack. Our stack name is called dev. And in here, you'll find stack-specific configurations like the US region and where the files for my static website are located. So next, we are going to take a look at my entry point file. In this case, it's called index.ts. And there's a couple of things here. First, you have your imports. Again, if you've written in TypeScript before or any other programming language, right, you start with your imports, then you follow configuration parameters, and then you define your resources. In this case, we are using 3 different Pulumi providers. One of the important one here is the AWS provider. So again, you are using native program-specific solutions to install and use the 150 plus providers. And they all follow the same convention, starting with at Pulumi. Now, the next thing here is we have our stack, which has some particular configurations, right? For instance, the AWS region. So for that, we want to consume that configuration to apply it to our Pulumi program. And we're going to do so by calling the config class. So with that, we're going to set our variables. And then we can now start creating our AWS resources. Now, keep in mind, again, that Pulumi is declarative. So what we're going to do is define the resources and then let Pulumi deploy them on our behalf. So we have an S3 bucket. The S3 bucket is going to contain a couple of HTML pages that we have specified. And also, right, S3, everything in S3 is private by default. So if we want global access to the contents in our S3 bucket, we do have to define a public access block and some ownership controls to be able to write to the bucket. And then we have a folder with our files. So as you will see here, there is an inherent dependency between my ownership controlled resources and my bucket resource. How do I know that? Because if we look at line 21, in line 21, I am referencing an output or a property, if you will, of my bucket object. Now, when I reference that property, Pulumi knows that there is going to be a relationship between the two and a dependency between my ownership control and my bucket. What that means is that Pulumi knows that it first has to create the bucket and then it has to go ahead and create the ownership controls, right? So in this case, there is an implicit dependency between the two resources. That may not always be the case. And for that, we do have additional parameters that you can attach to your resources to explicitly tell Pulumi that there is a dependency across these resources. Again, most of the time you will not need to create this dependency, but there are cases where you may need to. So then we have a CloudFront CDN resource. And part of the reason why we want that, right, is because we just want to cache our tiny website across the globe. Not only that, but we would like to have HTTPS for our bucket access. So for that, we have a CDN resource being created and defined here. So that's just all the details. Again, I did not write any of this code. This all came from an existing template that had everything pre-configured. So I would encourage you to start with that and then make changes to the template to fit your needs. We talked about inputs and outputs slightly. You could also think of these output properties of your resources. You can export them so that they can be accessible. You can access the values through the terminal. You could also see the values in the Pulumi cloud, which we'll see shortly. All right, so at this point, I have defined S3, an S3 bucket, S3 objects, some access control associated with the bucket, as well as a more complex CDN resource, right? So none of this exists yet. I am just defining everything I want. So how do we bring this to life? So this is where we are going to run the Pulumi up command. So the Pulumi up command is going to, in this case, use the dev stack, since that's the only one I have there. And it's going to, by default, generate a preview of what it is that it's going to happen, right? So at this point, we are not actually deploying resources. We are merely anticipating what are the changes that are going to happen when I actually fire up this thing. So this is an opportunity for me to review all the resources I have defined. And as you will see here, right, there is this inherent dependencies being identified by the Pulumi program. You can see it with the tabs specified. So if I agree to all the changes, right, all these resources are going to be created on my behalf in my default AWS account that I have configured. So if everything looks good, I am going to go ahead and confirm those changes. Now this may take a couple of minutes to deploy, especially because I do have a CDN, just to make it slightly more interesting. So while my resources are being deployed, you can see the progress here in the terminal. You will see that resources that can be deployed in parallel will, right? And this is to accelerate the time to provision all the resources. So because I am using Pulumi Cloud as my backend, which is the default, it means that I can have a copy of the progress by visiting my Pulumi Cloud account. So this is a good time to let this deploy and head over to our Pulumi Cloud just to get an idea of what's happening there. So in Pulumi Cloud, I can see all of my stacks that I have defined. I can get a high-level overview of all of my different Pulumi programs that I have created. Again, you do have a free individual account. This is what I use for my pet projects. And I can go ahead and see how my stack is doing. I can see all of the different updates, right? So there's a trail of history of everything that has been happening against a given stack. And I can see the progress. I can get a lot of details as to what is happening. So as expected, you do have the S3 bucket resources already created. The CDN typically takes a little bit longer, so we'll just give that some more time to finish. So while that's deploying, this is one of my favorite views in Pulumi Cloud is this graph view right here. So this graph view represents all of the resources that I have in my Pulumi program, as well as how they are related. So you can see here that I have my bucket. I have a bucket folder with 2 files. And soon enough, once my CDN gets created, the graph will update with the CDN resource. So we'll just go ahead and take a look at how it's doing. All right, so I think I tried this last night and it took just about 3 minutes to complete. So we'll give it a little bit longer. I do have a final version of this, just in case this takes a little bit longer for the live demo. But this is we do have a working version in the invite, in the Pulumi Cloud that you received an invite for. So this is a deployed version that I did last night of what's happening today. So you can see that there is these 4 outputs. So if we head over back to our code, right, I declare these 4 variables to be exported. Right, so these are called outputs, which means I can access them in the cloud or the CLI, and I can create dependencies on them. So in here, I have my CDN URL, right? Recall that the CDN URL, we added HTTPS, and then I have my actual bucket URL. So if I open my CDN, right here is my little application. It just says, hello world, deploy with love by Pulumi. So that's my CDN URL. And then I also have my original bucket URL, which I should be able to open. And here it is. So 2 versions of the same thing. The CDN has HTTPS. All right, so now that I show you the results, let's go ahead and see how our demo is going. And I'm going to sort by last updated because we have a lot of stacks in this particular cloud. All right, looks like it's done, right? I know that because I get a little notification that everything succeeded, and I have my CDN, and I have my original URL. So let's go ahead and see if this works. Yep, so this is the one that we just deployed. Alrighty, so with that, let's see what else we have. Yeah, let's go ahead and see if we have any interesting questions to share.
I think I covered most of it. Maybe the only one which makes sense to talk about is what the options to manage the state file of Pulumi. Then,
Yeah, that's a great question, and I will say if you have the option to use Pulumi Cloud, I will highly encourage you to use Pulumi Cloud because it manages the state for you. And managing state is, I would say, one of the biggest challenges in adopting an infrastructure as code solution. You can also use S3. You could use a local backend, which is sometimes useful for when you're developing something locally and you kind of want to mess with it. You can use a local state backend. You can use an S3 bucket for your state backend. You can use Pulumi Cloud, and I believe I'm missing a few more, but we do have a link to, let's see if I can find it.
It's already I posted it.
Oh, okay, perfect. Yeah, we do have a link to that. Yeah, the one thing, another advantage for Pulumi Cloud is the secrets management. Pulumi Cloud generates a key per stack, and it uses those keys to mask anything that you declare as a secret in your dev stack file. Any other questions?
I think we covered everything for now.
Okay. Alrighty, perfect. So before we go back to the slides, something that is always a good practice is to clean up our resources so that we are not incurring additional costs. The way you can tear down the resources is by running the Pulumi destroy command. So Pulumi destroy command is going to say, hey, all the resources that you have defined, let's just go ahead and remove them because the user has requested them to be removed. So again, just like Pulumi preview, like Pulumi up, right, by default, you are going to get a summary of what is about to happen. That way it gives you an opportunity to review any changes before actually committing to it so that you're not inadvertently deleting things that you didn't necessarily want to. So we're going to go ahead and clean up all of our resources. Right? We're going to delete 8 resources. So everything looks good. I'm going to go ahead and click yes to confirm the destruction of my resources. Now, similar to Pulumi up, right? If it knows that resources can be destroyed simultaneously, it will go ahead and do so to accelerate the teardown process. If I head over to my Pulumi Cloud account, I can see that there is now a new update that was detected, which is a destroy. And similar to what I can see in the terminal, I can also see it here. It will remain there pretty much indefinitely. That way you can have a trail or audit, if you will, of all the changes that have been happening over time. All right, so that wraps up our first demo. So let me go ahead and switch over to our slides. Okay, so this is where we are in our infrastructure CI/CD pipeline journey. Right? The first thing we did was define infrastructure as code. We did so using Pulumi and the TypeScript programming language to define a cloud resources. So that's really it, the initial phase for having an infrastructure CI/CD pipeline. However, there is more to it. So in order to truly have a continuous pipeline, we actually have to automate some of the steps that we just did, right? So we ourselves, like a human being, had to sit in front of the terminal and type Pulumi up and type Pulumi destroy. Now, if we want to adopt more of your DevOps slash GitOps practices, right, we want to ensure that these commands are performed programmatically, right? We don't want to necessarily have a human sitting in front of a screen to deploy cloud resources, right? We want to automate everything end to end because that is what gets us the best performance for deploying software and, in this case, infrastructure. So this is going to bring us to the next demo, in which we are now going to essentially automate the steps we just did in the Pulumi, in the terminal, right, with the Pulumi CLI. So what does that mean? It means that if we are adopting a DevOps mentality, right, we want to have version control, number one, and typically we want automatic testing of our infrastructure changes. So what does this mean is that every time I make a commit against a pull request, I will like to preview the changes to make sure that it is what I expect. Right, so we want to automate this process. In addition, when I happened to merge a pull request, right, I want my infrastructure to automatically deploy. Right, so automatically build and deploy. So what we need to do is we need to automate the Pulumi preview command, and we also need to automate the Pulumi up command. So before we do so, I want to quickly also introduce Pulumi AI. Pulumi AI is free for everybody to use. So just how we used a template to bootstrap our Pulumi program, I would also encourage you to check out Pulumi AI as a way to accelerate your infrastructure as code development. I can prompt Pulumi AI to create a static website, which is what we just did. And it can go ahead and give you an example in all of the different programming languages that we support. Now, of course, like any AI model out there, it's not perfect. However, I find that it can help me get much more closer to development than if I were to start out from scratch. So something I encourage you to do, in addition to checking out the Pulumi templates, to help you accelerate your infrastructure as code development. All right, so again, we are using Pulumi Cloud, as you saw earlier. For today's demo, it is the fastest way to get started. I think Marina shared some great links for other alternatives for handling your state file. So definitely take a look at that. I do have an individual account, which is what I use for my pet projects. Alrighty, so let's go ahead and move on to our second demo. So how are we going to automate, right, those Pulumi commands we saw earlier? Well, Pulumi also has, in the GitHub Marketplace, we have a Pulumi GitHub action available to use, which is what we'll be leveraging today to create and finalize our CI/CD pipeline. The way that GitHub Actions work, right, there is a marketplace with hundreds of GitHub Actions in there. Some are really good ones, right? You can find something like to automatically link your projects. And we also have the Pulumi one. The way you use it is, as I'll show you shortly, you have to create a YAML file in which you reference the Pulumi GitHub action. So with that, I am going to go ahead and switch gears to my Visual Studio Code. So I'm going to share my screen again. Okay. So I have a different repository now. So the infrastructure done, right? This is everything we did earlier, right? Where we have our stack file, our YAML file, and whatnot. Of course, part of DevOps means using source control. We are using GitHub. So in order to use GitHub Actions, right, we have to follow the process for that. And the way it works is at the root level of my GitHub repository, I have a .github folder. Within that, I have a workflows subfolder. And in here, I am going to go ahead and define all of the different actions that I want to perform programmatically. Now, the two that we are going to focus on today is branch and main YAML. The done ones, I just put those together last night, just so that we have a final working version in case things take a little bit longer than we would like. So let's go ahead and take a look at our first GitHub action. Again, all of this code is available in the Handouts tab. There is also a pretty detailed README file with step-by-step instruction covering everything that we're doing today. So you don't have to worry if you don't capture everything right now. You do have links to all of the code for today. So first, we are going to create a GitHub action, and we're just going to call it branch. Not very creative, but it works. So what does this GitHub action do? So the trigger, right, is defined by the code that I have highlighted here. So what this is telling us is that whenever there is a pull request on my main branch, and there's also when a commit is done against a pull request on my main branch, whatever I have defined here is going to take place. And what do I have defined here? Well, what is interesting to us is we would like to preview all the changes that we're expected to see in the cloud, right? So essentially, we are finding a way to programmatically handle the life cycle of all of my cloud resources. In order to work with GitHub Actions, right, there's some syntax that we have to adhere to. So we have the idea of jobs, and we give the job a name. So what is Pulumi Preview? So Pulumi Preview is essentially that confirmation that you saw in the terminal before I went ahead and clicked yes to confirm the changes. So I can actually show you. So let's go ahead and head over to our infrastructure folder. And in here, if I do Pulumi Preview, so now instead of doing this manually, whenever I commit to a PR, this summary will happen automatically. And this allows me to validate that everything I have defined in my PR is what I want before actually proceeding to merging the changes. So there is some standard steps that we typically see in GitHub Actions, but the ones that are specific to my Pulumi actions is right here. I'm going to go ahead and highlight it. So GitHub Actions, right, the command that we're doing is called preview. We have to give it the fully qualified stack name. So what is the fully qualified stack name? It's actually the name of your organization, followed by the name of your Pulumi program, and followed by the stack name of interest. Because we have multiple things in our directory, in our repository, we have to specify a particular directory that we want to look at. So the next thing is the environment. So in order to configure GitHub Actions, it does require some variables. And in particular, if you are using Pulumi Cloud, you will need a Pulumi access token. So I'm going to go ahead and quickly show you how to go and get your access token. So give me 1 second, and I'm just going to go ahead and bring where are you? Here you are. Okay. So if you are in Pulumi Cloud, you can go ahead and click your profile, go to personal access tokens, and create a token, give it some kind of description, and create it. Now, I've already gone ahead and created a token for today's demo, so I'm not going to go ahead and recreate one, but that's how you do it. You do have to store your AWS credentials in your GitHub repository. This is one way of doing it. You'll see in the advanced version of today's workshop that you don't necessarily have to store AWS credentials in your GitHub repository if you are using Pulumi ESC, which we'll talk about shortly. So how do I store these credentials in GitHub? Let me go ahead and get my credentials first. So we are going to do so. Go ahead and get my notes. Alrighty, so I have a bunch of credentials to paste. And the way I do so, I can do it in the terminal or I can do it in the GitHub UI. Well, let me just go ahead and show you here. Secret. Okay. So this is what I did earlier. So I do have the GH command line installed. So I can declare my secrets. So I'm just gonna go ahead and declare my Pulumi access secret. And then I am going to do the same thing. So it's gonna take a little bit of time just because I have to set up 3 different credentials. So bear with me. So let me go ahead and get my access key as our accounts do use short-term credentials. So I'm just gonna go ahead and enable these 3 things. That way I can ensure that things are working. Now I'm going to go ahead and set my access key. I'm going to go ahead and get that value. Okay. And last but not least, I am using a session. So we want to go ahead and save my session token, which is very large. So let me go ahead and copy my session token and paste it in. Okay. So I can go ahead and look at the secrets list that I just added to my GitHub repository. So this will allow the Pulumi GitHub action to have all the credentials needed to access the Pulumi Cloud and also access my AWS account so that it can deploy cloud resources on my behalf. All right, so now that we have that configured, we should be good to go. I also have another GitHub action, and this particular GitHub action is going to trigger whenever I do a merge on my main branch. So the difference is that this will actually run a up command, and the up command is going to be the one that actually deploys the infrastructure, right? So we talk about CI/CD. We want continuous integration, which is our automatic test which is then translated to Pulumi preview. And then if we want to maintain maintain the code in a releasable state, that's the other GitHub action that does the Pulumi up command to ensure the resources are available. So that's the only difference here, is when the action triggers and what the action does. Right, so in this case, we are doing an up command. I don't have to set my environment variables again. Right, this is on a per GitHub repository, and I've already taken care of all of my environment variables. All right, so now that we're here, the next thing to do is to actually commit the changes to my GitHub repository, because that's what will trigger the GitHub actions. So if we're here, let's just quickly do a git status and recall that we now have all of those. So I'm just going to add everything. So these are all the files from the Pulumi template that we created earlier. So we want to go ahead and commit those changes. In this particular, I already have a branch called feature CI/CD. So we are doing or trying to adhere to trunk-based development. What that means is that you typically want to have feature branches. You commit often and you merge often, right, to avoid when things go awry, to avoid having to spend a lot of time debugging. So let's just call this live workshop. And let's go ahead and push our changes. So I actually don't have a PR. So we're going to go ahead and create a pull request against my repository. We're just going to kind of skip over this and go ahead and submit it. So I can actually go ahead and take a look at my pull request live. So what we expect to see is that as soon as I push the changes, my commit, right, the GitHub action that I have defined is going to trigger, which means it's going to preview my infrastructure. So let's go ahead and push our code. Okay. And looks like we're good. Alrighty. So let's take a look. Looks like I have some issues here, so just bear with me 1 second. Because I was trying to get a okay, so let me take a look at my alrighty. So here we go. So I went ahead and committed my changes against a pull request that's open against my main branch. Now recall that I have defined 2 GitHub actions, one of them to trigger on commit, and this is triggering right here. So I can go ahead and see the details of what's happening. All right, so now I should be programmatically performing a preview, right, as you can see here, of my infrastructure changes. So this might take a little bit of time to complete. So we'll just let that run. Okay, actually that was a little faster than I anticipated. So let's go back to the pull request that we just opened. Okay. So I can see now that I automatically have a check. Oops, sorry, go back one. Right, a check. You can ignore the one that's done. That's the one I did last night. So if everything looks good, I can now go ahead and merge my changes to the main branch. So once I merge the these changes, it's going to trigger the other GitHub action that it's meant to actually deploy my infrastructure changes on AWS. So if I head over to my Actions tab in my GitHub repository, right, I can see that we are having a GitHub action automatically run against my main branch. So I can go ahead and open it. So this should do the Pulumi up. So again, this might take a few seconds because we're actually deploying or instantiating infrastructure. In particular, this is our S3 bucket, right, those object files, and my CDN. So I tore it down, and now I am bringing it back up through the GitHub action. So this is just performing everything one step at a time. I can actually head over to Pulumi Cloud and see the changes taking place as well. So if I come back here to my dev, I can see that there is a loading icon here. So this is what's currently happening, and I have a lot of information as to what's going on. So instead of me having to run Pulumi up in the terminal, the GitHub action is performing that activity on my behalf, which gets us to that continuous development practice. This is going to take some time to run. So I'm just gonna go ahead and in the meantime, switch over and see if there are any interesting questions. Alrighty, so let me switch over to the slides. And looks like we have some questions here. So we have two questions from Andres. So how do you intend to programmatically obtain the AWS credentials when running GitHub Actions to truly perform GitOps? That is an excellent question. And for that, we have a solution called Pulumi ESC. With Pulumi ESC, which we'll actually talk a little bit about shortly in more detail, you can have AWS OICD credentials configure. And if you recall that stack file, in that stack file, you actually point to a Pulumi ESC environment that performs your AWS OIDC credentials. I can actually show you this somewhat, just so that you have a bit more context how you will do this. And this is actually one of the activities that we will be doing in the second version, the more advanced version of today's workshop. So while these resources are still deploying, I talk about Pulumi ESC. So Pulumi ESC allows you to define environments, including, of course, AWS OIDC credentials, which is what we would do. Now I forget which one is mine. I believe this one is mine, so I can show you this one. So what you do is you define your environment, which has all the environment variables. And in this case, I have my environment name is called AWS OIDC/env. So what that means is that when I head over to my stack file, instead of defining those credentials in the GitHub repo, I will actually have a reference. Let's see if I can spell that right. And a reference to my environment. So that is all I would have to do. And then this allows me to get rid of my AWS credentials in my GitHub Actions. Alrighty, thank you for the update. All right, so let me go ahead and share my screen. Okay. Alrighty. So here we go. Sorry about that. Okay, so what I did is I have an OIDC environment set up in my Pulumi Cloud account. This Pulumi Cloud account is what is doing the OIDC login. And in my stack file, I have a reference to the environment that contains the OIDC credentials. Alrighty, so hopefully that helps a little. Let me head back over to the questions. There is another question here. Is there a way to prevent up if there are no changes in preview? I'm guessing this means that you don't want to run Pulumi up. You can do a preview with a flag called expect no changes. And what this means is that if the preview results in changes in that PR, you will get a failure, right? Because changes occur even though you told it expect no changes. So I will encourage you to check out that flag and introduce it in the in our case in the branch GitHub action. So that's most likely what you are looking for, but let me know otherwise. Let's see, looks like we have another question here. Setting true color, looks like there is perhaps some kind of bug in our GitHub Actions. If that's the case, our GitHub Actions is open source. What I would encourage you to do is go ahead and create an issue if there already isn't an issue created for the particular bug that you're facing. And I would also encourage you to share a link to the issue in the Slack community channel, which I'll show you towards the end of the workshop. That way you can get a little bit more insights as to what our engineering is looking into. Unfortunately, I am not in the engineering team, so I don't know what the plan is, but I will say get an issue file if there isn't already one. Query about this particular bug that you're facing in our community Slack channel. That way you can get a better answer. All right, all great questions. Let's see what else. Is there any other questions I may have missed?
I don't think so. For some reason, people complain that they cannot see your screen. I can see right now we're in a QA, but if you switch between like when Diana was sharing the screen, I don't know what we missed, guys. Just let me know because I definitely saw it.
Okay.
Yeah.
Yeah, and I feel like it may have been when I was projecting the questions. It was covering my screen there.
Yeah.
Okay.
And let me give Elsa a link to Pulumi Slack because this is a quick way to find answers.
Yeah. And in the meantime, I am going to go back and share my browser. So my GitHub action was running while we were answering some questions, and looks like everything went through, which means if I go back to my stack, go ahead and find my stack here. Let's have a lot of stacks here. All right, so this is the one for today. All right, so the latest update went through, it created all of my resources, and now I have my CDN URL as well as my bucket URL. So, which means if I access this URL, I should be able, let me just try that one more time. I already had something open. Let's go ahead. All right, there we go. There is our hello world message. So all the infrastructure that we defined in our Pulumi program was deployed via the GitHub Actions, and it triggered as soon as I merge my changes into the main branch. All right, so let's go ahead and head over back to the slides. So again, this was our Pulumi GitHub action to deploy AWS resources on our behalf. So at this point, we have practically finished our CI/CD pipeline. Everything we did today is under my personal repo, under the live workshop. However, you do have a link to a more permanent location in the handouts. So we built an infrastructure CI/CD pipeline from beginning to end by defining infrastructure as code. We then created 2 GitHub actions to help us with steps 2 and 3, right? To test and commit, we do Pulumi preview. To merge the changes, we do Pulumi up. So today we show you GitHub Actions. I just wanted to make you aware that it is not the only CI/CD option that we offer. We have a lot of various ways of working with other popular continuous delivery solutions. So certainly encourage you to check them out if perhaps GitHub or GitHub Actions is not your go-to choice. But just wanted to bring that to your attention that there's a lot more than just what we showed today. And if to find out more details, there is a link here that will take you to all of the integrations that we offer. Alrighty, so now we are going to slightly pivot. I'd like to cover some of the more advanced topics and things that you can do with Pulumi as you mature in your journey. This is what we call Pulumi for platform teams. So you may find a lot of these topics relatable just based on the poll where I think most of you had a platform engineering and DevOps background. If you don't, I just wanted to quickly define the term because we hear this a lot, and I really like this definition from our CTO, Luke, where he states that platform teams is a way of building out core cloud infrastructure and providing tools for everybody else within your company. Just gonna give that a few seconds. Okay, so Pulumi for platform teams, it's really a set of features or offerings that we have mostly with our Pulumi Cloud offering. So today we saw the GitHub app. There are also a few other things that you may want to be aware of. One of them is the automation API, policy as code, Pulumi ESC, which I sort of touched upon already, and last but not least, Pulumi deployments. Now, I want to take this time to say that we do have an advanced version of today's workshop, which is a continuation of what we did today. And in that advanced workshop, we are going to be doing policy as code, Pulumi ESC, and deployments. So today I'm going to talk about them. And in the advanced version, we are going to actually implement these last 3 items here. So to briefly cover some of these Pulumi platform features, first you have the automation API. The automation API, you could think of it as a way of automating all of your Pulumi CLI commands in your code itself. This allows you to do things like complex rollouts. You could do like blue-green deployments and so forth. Some of our customers will use the automation API to build internal developer platforms. You may have heard of the Backstage plugin. I believe there's some automation API with our Backstage plugin. So that's certainly, if it's something of interest, something worth checking out, of course. Then we have policy as code. We do have an open source version of policy as code, which is great. I will say it literally takes about 30 seconds to have CIS compliance or many other out-of-the-box ready packages to work with your Pulumi program. The way this works is you have a cloud, say AWS, you have a service, say S3 severity, right? So you could enforce it or give a warning depending on the type of rule that you have. And the combination of these three things is what defines rules that you can enforce with your code. So this can help you, have something like, hey, let's prohibit the use of anything larger than a T3 medium in your dev environment. Right? So there is a way to codify those kinds of policies and compliance using either, I think we offer Node.js or Python. And this is something that we will be doing hands-on in the next workshop. Then we have Pulumi ESC, which I briefly showed. Pulumi ESC stands for Environments, Secrets, and Configuration. The idea with ESC is that you can define hierarchical environments. Right? So you can import, as you see in bullet number 1, you can import one environment from another. And you also have both static and dynamic values. Dynamic values are great for things like OIDC, right? So these values are resolved when you need them. So you can see here in item number 2 that you have your access key ID for AWS, and that is a reference to something that gets resolved dynamically. You can also consume the secrets that you define in your environment from a number of places. There is a Pulumi ESC CLI available. You can also use the Pulumi CLI if you already have that local. And as I showed very briefly, right, you can reference these environments directly in your Pulumi stack files, which is the example that you see here at the bottom, where you have an environment and then you have a reference to whatever you have defined in the Pulumi Cloud ESC. So with that, we have also a fully managed CI/CD offering. This is sort of like the next kind of enterprisey level of doing CI/CD at scale. The offering is called Pulumi Deployments. So unlike GitHub Actions, where we are triggering them via a Git push, you can also trigger your workflows directly from Pulumi Cloud. So you can centralize that behavior within Pulumi Cloud. One of my favorite things, and something that we'll be doing in the advanced version, is review stacks. So review stacks are ephemeral environments. What that means is that just how before I had that Pulumi preview command on every commit, I can actually have a ephemeral stack that instantiates my resources. Something else happens against those resources, perhaps some sort of application testing, and then those resources get torn down automatically. So it's a programmatic way of creating a temporary environment, running something against it, and then tearing it down right away. So those are your review stacks. There is also OICD integration, and similar to GitHub Actions, you could have managed runners or self-hosted. Alrighty, so there are a couple of very relevant upcoming workshops that we have. One of them is happening early next week, and that is we're going to be doing an advanced CI/CD pipelines using Pulumi and GitLab. So I encourage you to check that out if you're interested in this topic and perhaps seeing a solution with an alternative to GitHub Actions. If you are new-ish to Pulumi, I would also encourage you to jump into our Getting Started with Infrastructure as Code which will walk through, in this case, a Python example to deploy AWS resources. And last but not least, I have mentioned throughout today's workshop, we are planning on launching an advanced version of today's workshop. We do not have a set date, but I encourage you to check out our resources page for any updates and upcoming events. Alrighty, let me go ahead and switch over to essentially the summary of what we have achieved today, and also open it up for any other questions that we have not answered. Alrighty, so I see, let's see. I see 2 questions, so I'm gonna go ahead and project them onto the screen here. Does the previously configure OIDC override the AWS credentials? Looks like this was from earlier, so I may have lost some of the context here, but I am guessing, if I'm understanding it correctly, it means comparing the credentials defined in GitHub Actions versus the credentials defined in Pulumi ESC for AWS OIDC. So if that's the case, what you would have to do is in your GitHub Action YAML file, and I can actually show you. Okay, so let me switch back to my screen. So I believe this is what it means is that, say you have your credentials hard-coded, but then you decide to include, to migrate over to Pulumi ESC. All you have to do for your GitHub action is just get rid of that reference. So that will clear it up from your GitHub action, and it will then pick up your OIDC credentials from your stack file, which in this case is right here. Right, so now I have a reference to my OIDC environment. So that way you're guaranteed to use whatever is defined in Pulumi ESC versus what may be defined in your GitHub repository. Okay. So it looks like we have another question here. Implement automated testing for infrastructure as code changes. Okay, so to implement any test, so this is something that Review Stacks, so both Review Stacks, the automation API, and Policy as Code can help with testing your infrastructure as code. Also keep in mind that because you are leveraging your known programming languages, you can use whatever the programming language offers to test your infrastructure for anything like unit testing to integration testing. So if you want to do this, something that will really help here will be to check out Review Stacks, where you can create that temporary instance, test your changes, validate any outputs that you expect, and then tear it down. Okay, so please go ahead and ask any of your questions that you may have. We are getting very close to the end here. Actually, we have like 4 minutes to spare, so we're doing really good on time. So today, infrastructure as code, do GitHub Actions to test, commit, and build, deploy. Alrighty, so with that, we are getting to our last slide. You will get an email in the next hour or so asking for your feedback. We do look at that feedback to improve on our workshops, on material. So please go ahead, and I encourage you to fill the feedback form. It takes a couple of minutes, if not less, to complete. So please go ahead and do so. That'll be a great favor to me. And of course, if you have not yet obtained your free forever Pulumi Cloud account, you can always do so. We are in social media. We are on Twitter, Slack. We have a Pulumi TV channel, as well as, of course, our GitHub repository. So if there are not any more questions, we are going to be wrapping up for today. Thank you so much for all your great questions and for attending. If you have any follow-up questions, I highly encourage you to join our Slack channel. And there is our Slack community, and there is a AWS channel in there. I am there. Marina is there. We can try to help with any follow-up questions. So with that, thank you so much. Enjoy your weekend, and I will catch you on the next one.